proportion theorem that we discussed yesterday. You can see that we have two lines that are parallel. So, first thing, you need to identify a triangle such that you can use the proportion theorem for that triangle. But the following information that's given is very important. We are given a line, two lines that are parallel, and we are also told that AN is perpendicular to DE. Furthermore, we are told that AD over DB is equal to 3 over 2. So, first thing, I'm going to use the proportion theorem. So, I'm going to write in triangle, okay, the triangle which I'm going to use to answer the problem, that is 11.1.2, that's 11.2.1, I'm going to use this triangle, okay? That's the triangle, so I've got AM, so that's the triangle that I'm going to use. So I know that those two lines are parallel. So I'm going to name the triangle. So I'll say in triangle ABN. Okay? Now in triangle ABN, if I use the proportion theorem, because already I know that DM is parallel to BN. Okay? So I can write based on that equation, means I have AD over DB. Okay? And then here I have AM over MN. So that's AM over MN. So I can directly use my proportion theorem. It's always wise to provide more information when you're answering geometry questions than less information. So I'm going to write AD over DB is equal to AM over MN. And my reason is the proportion theorem reason. That's line parallel one side, we can put to one side here, line parallel to one side of triangle. Or if you don't like this reason, you can write it as proportion theorem. Then you must state the lines that are parallel. So in triangle ABN, we are going to have DM is parallel to BN. Right? So any of these two reasons are acceptable. Okay? As I told you in class yesterday, I prefer the first one. But you can decide which one you prefer. Now, once I write this, I now know that that's my equation or my statement. But I know that AD over DB is equal to 3 over 2. So I can straight away write therefore AM over MN is equal to 3 over 2. Right? It's 2 marks, so you might get a mark for this statement and the reason together, or they might give a mark for the reason only there and then the other mark there. Okay? So there are two scenarios. Either this statement here may be given a mark together with the reason. That's why it's very important for you to write this. Okay? If the memo allocates a mark for both the statement and the reason, and you write the reason only or the statement without the reason, you end up getting 1 out of 2 if your final answer is correct. So make sure you don't forget to write this together with the reason. Okay, so that's the way you approach the question. Never rush to just write, okay, AM over MN is equal to 3 over 2. Make sure you start from the basics of the proportion theorem. Okay, now let's move on to number 2. So to the next question. But before I move on, for the first time, right? You might have a challenge to realize how you can find it. But I want you to be aware that sometimes the questions on the proportion theorem, they can be combined with similar triangles. Now, before I carry on, what do you still remember regarding similar triangles? What are the two conditions for, okay, on my diagram, I'm going to put my ratios. Remember the concept of ratios that I introduced yesterday. We are going to apply it now. So, for AD, I can call the length AD because based on that ratio, I can call it, okay, let me use Y, I'll call it 3Y. Okay, that's AD. And my DB is going to be 2Y. Okay, now the one for AM, right? The one for AM, I'm not going to be worried about it because I want to use triangle ADE. Okay, first I have to prove that triangle ADE is similar to triangle ABC. Okay, so I'm going to use triangle ABE and triangle ABC. Okay, those two I'm going to prove first that they are similar triangles. Then after that, I can carry on to determine the ratio of DE over BC. I'm not worried about AM over MN. I'm now concerned with AE over CE. So, if you look at it, you find that DE is parallel to BC. So, it means that I can use the proportion theorem in triangle ABC. If I do that, I can call this side here based on the ratio. I can call it. Let me use a different color there. That one, right? And I can call it 3x, and that one I can call it 2x. Right? This is very important. We can use two different constants because the two line segments are not the same. Okay? We can't use the same constant for both uh, AB and AC. Okay? If we use the same constant, it means we are saying the two sides are equal. So we have to use two different constants. The x and the y are the constants that you can multiply the ratios with to determine the original length. So if I use the proportion theorem in triangle ABC, it means AD over DB is going to be equal to AE over what? Over EC. Okay, so on the next page now, I'm going to identify two triangles that are similar so that I can carry on. So my two triangles are ADE and ABC. Okay? So to do 11.2.2, I'm going to say in triangle ADE and triangle ABC, okay? We have to prove that those two triangles are similar for us to say that their sides are in proportion. I'm sure you can all see that DE and BC, from your knowledge of similar triangles, they have to be sides that are in proportion with, say, AD and AB. Okay? So, firstly, we have a common angle. Okay? We have a common angle. So, I'm going to write number one, angle A is common. Okay? And remember, the naming of similar triangles is very important. I started with A here, so I also have A there. Okay? Then, number two, if you go back here, you find that since DE is parallel to BC, it means this angle, that is ADE, is equal to angle ABE because they are corresponding angles. So I'm going to write that. So here I'll say angle ADE is equal to angle ABC. And my reason, corresponding angles, okay, the two lines that are parallel, it's DE is parallel to BC. Right? Then, the third pair of angles, this angle here, AED, angle AED and angle ACE, they are also equal. Right? So I can also say they are corresponding angles. So it will be angle AED is equal to angle ACB, and they are corresponding angles, and then DE is parallel to BC. Okay, then I can say therefore triangle ADE is similar to triangle ABC. And my reason, I can write here triple A, or you can write equiangular triangles. Okay, so now that I have proved that that pair of triangles is similar, I can now go and write now that the ratios of the corresponding sides are equal. So I can now just write therefore AD over AB will be equal to DE over BC, which is going to be equal to AE over AC. Why is this true? Because triangle ADE is similar to triangle ABC. Okay? Now, I'm almost there. So, from there, remember, what is the objective? To determine the ratio of DE over BC. So if I go back to my diagram, right? On my diagram, I have the length of AE, I have my length for EC, I have my length for AD, and I also have my length for DB. Now, for triangle ADE, if I want DE over BC, okay, remember that's the one that I want. DE over BC, okay? So I can choose, say, AE, I can choose AE and AC, okay? So AE is equal to 3x, and AC is going to be 2x. So it's 2x plus 3x. So let me move on to the next page. Right? I have to tell you the next page. So I'm going to choose this combination to do my answer. So I'll say DE over BC is equal to, right, therefore, is equal to AE over AC. Okay? And this is equal to our AE. If I go back to the diagram, AE is equal to 3x and AC is equal to 3x plus 2x, which is 5x. So I'll end up having 3x over 5x. So DE over BC will be equal to 3 over 5. Right? Remember, the question is asking for a value. Okay? The question is asking for a value. So this x and that x cancels because it's a common constant. Alright? Okay. So now we need to find the ratio of the area of ADE divided by the area of ABC. Okay? Now, it's very important for you to know that your area, as I told you yesterday, from your previous grades, it's half base times perpendicular height. Okay, now if we can't use the concepts that are introduced yesterday with regard to the proportion theorem, then it means we have to use another concept. So here, if you go back, we want ADE over ABC. Okay, so if you look at that triangle, we want the area of ADE over the area of ABC. What is the ratio of their areas? Now, if you look at it, I'm sure you can see that the two, though they have a common vertex here, they don't have a common height. Okay, but we are told that AN is perpendicular to DE. So this angle is 90, that angle is 90. Okay, so I need to introduce a third set of constants, or rather of lengths that involves a constant. So in terms of A, okay, remember what's here? It is AM here. So AM, I can write it as, say, 3K. And my MN, I can write it as 2K. So I'm introducing a third constant to make things easier for me to determine the area. Now, I'll show you two ways of doing the problem. We can use the area rule as well. Okay, I'm going to use half base times height, then I'll use the area rule to do the same question. Okay, so if you want to find the area of ADE, it's going to be half base times height. Our base is going to be DE. Okay, our base is going to be DE and our height is going to be AM. For triangle ABC, our height is going to be 5K and our base is going to be BC. Okay, so here I can say area of triangle ADE over area of triangle ABC. This will be equal to a half times. Now, the base for ADE, remember, it's equal to DE times the height, which we know is now equal to 3K, all over. The area of ABC is going to be, the base is BC, and the height is 5K. All right, please, before I carry on, I need DE is equal to 3 over 5. Okay, these two will cancel out, and that K will also disappear. Right? We know that the ratio, so we can end up having DE over BC is equal to 3 over 5, so we can write this as 3 over 5 times 3 over 5. And the final answer will be 9 over 25. So that would be the ratio of those two triangles. Right? So in this case, I'm sure you can see that the ratio of their areas is equal to the square of the ratio of their bases. Okay? That's also a very important concept when you are dealing with similar triangles. Okay?